All right, 9.5a, the binomial theorem. What does bi mean? Two. All right, so we're going to have two terms. In this case, we're just denoted by x and a y. We're going to have not just x and y here. They're going to be something. Now, we're going to raise that binomial to certain powers. And I want you to see some things when we raise things to certain powers. If I raise it to, let's say, to a power of 4, all these exponents will add up to 4 on each term. All right, so if I have an x to the 4th, then I have an x cubed, and then a y to the 1st. And then I have a squared and a squared. So 2 and 2 still add up to 4. All right, so whatever your power is, your exponents will add up to that. Now, there's also something else that I want you to notice from it. The beginning term, guess what these exponents do? They descend. So I go from 4 to 3 to 2 to 1 to 0. And then the other term, this second part of your binomial, they ascend. All right, so it goes from y to the power 0, y to the power 1, y to the power 2, y to the power 3, y to the power 4. All right, so your first one descends in power. Your second one ascends in power. Does that make sense? All right. What the binomial theorem is all made of. All right, I want you to write this out. So if I have x plus y to the power of n, this is how you get any term. This is how you get any term in your binomial expansion. It's n combination r, x to the n minus r, y to the power of r. And you're going to hear me say this a lot, and I did this when I taught Algebra 2 last year. If you find your r, you got everything. All right, r is the most important in this. If you can understand what your r is, then you got it all. All right. I also need to teach you a couple things about notation. One way to denote a combination is in combination r, like that. Or you can write it as like an elongated parenthesis. You have in combination r, except it doesn't have a c. All right, and I'm going to switch it up to go both ways. Now, this is your old school in combination r. I'd like you to write it down. This is where it's coming from. Now, you're going to have a calculator on all your assessments on this, but I'd like you to at least know where it comes from. All right, I'll teach you how to do it with your calculator, but I want you to know where it comes from as well. All right, so it's evaluated by n factorial over n minus r factorial r factorial. All right. Find the binomial coefficients. Before we do anything as far as our terms go, it's easier just to find your coefficients to begin. So this first one, I have 8 combination 2. So we're going to build this old school at first. All right. So if I have 8 combination 2, that would just be 8 factorial over what? 6 factorial and then 2 factorial. Now, you had this on your quiz just a moment ago. How do I want to think of 8 factorial? 8 times 7 times 6 factorial. And then I have a 6 factorial down there, and they cancel. And then what's 2 factorial? It's just what? 2. All right. And so really you could kind of think of like, well, 8 divided by 2, well, that's 4. And so I have 4 times 7, which is 28. And so I have 8 combination 2 is 28. That's how it's actually used. All right. Part B, I have 10 combination 3. All right. So 10 combination 3 is really just what? 10 factorial over 7 factorial, 3 factorial. All right, and so how do I do that one? What is 10 factorial? 10 times 9 times 8 times 7 factorial. And then my 7 factorials, they cancel. All right, and then I still have 3 factorial, which is just what? 3 times 2. Well, if I were kind of to do this by hand, 9 divided by 3 is 3, so I have a 3 up there. 8 divided by 2 is a 4. And so 10 times 3 times 4 is 120. All right. All right, let's do this next one. I have 7 combination 0. All right, so what would I have up top? 7 factorial over 7 factorial times 0 factorial. It's just 7 minus 0. It's the n minus r. All right? So 7 factorial over 7 factorial, those cancel to be 1. And then 0 factorial is also what? 1. So we end up with 1. All right, let's look at D. That means 8 combination 8. So what's up top? 8 factorial over 0 factorial and then 8 factorial. All right, so again, we end up with 1. All right, now get out your calculator. I want to show you how to use your calculator. If you have a graphing calculator, I want you to go to Math. Okay, go to Math, and then the fourth column over, I think, is Prob. And then I think the second or third thing down. The third thing down. There's your in combination R button. All right, and then you just kind of fill in the blanks. All right, so just check it to see if you can get like 10 combination 3 to see if that one works. All right, McKinley, 7 combination 3 is 35. All right, pick somebody. Zach, what we got? 35. All right, pick somebody. 12 combination 1 is Cooper. 12. Pick somebody. 12 combination 11 is Skipper.
Is it 12?
It is 12 again. All right. All right. Pretty good. All right. So this is probably what you remember in Francie Payne's class with binomial expansions. All right. This is Pascal's triangle. And Pascal's triangle is good for the very first few terms. All right. It's very good for the first few terms. However, if you're going to have like, let's say the 15th power, would Pascal's triangle be a good option? No. All right. It wouldn't be a good option. However, Pascal's triangle is kind of nice to see some things. All right. For instance, if I have a 0 power, it's just 1. If I have a 1 power, there we go. If I have a 2 power, that's my line for my coefficients and so forth. Now, what Pascal did is he noticed that if you build this little triangle, if you have like these two terms, if you add them together, you end up getting that term. All right. And it's very useful for the very beginning ones. Another thing that I want you to notice, if I say, let's say we have a 5th degree, what's my first term always? 1. And then my second one is 5. Now my last one is 1, and my second to last one would also be what? 5. All right. That is very important. All right. So if I have a power of 12, what's my first term going to be? 1. And then my second one is 12. My very last one is going to be 1. My second to last one is going to be 12. All right. Now, you could totally add these things up forever and ever. However, once we get into higher powers, it's not going to be fun to use Pascal's triangle. It's very limited. Now, the first four, totally memorize them. Okay. They'll be very useful to memorize them. All right. All right. Let's play. Here. So we're going to use a 7th row Pascal triangle to find these binomial coefficients. Now, also, I forgot to go over it. If this is my 3rd degree row, how many terms do I have? I have 4 terms. Because this term right there, that 1 right there at the beginning, is actually, what is my R? My R on this one is 0. Okay? Because this one's going to be a 3. All right? So this one's 0, and then this one's 1, and this one's 2, and then this one is 3. Does that make sense? All right? So if I have 7, if I have a 7th degree, how many terms am I going to have? I'm going to have 8. If I have an 8th degree, because this is what I'm actually doing, if I have an 8th degree, how many terms is it actually going to give me? 9, because we start out at 0. Okay? All right, before we even do this, I want to freestyle. If I let's say I need the, no, I don't want to do, let's go 5. Let's say if I have the 5th term. If I have my 5th term, what is my R of my 5th term? If I want my 5th term and I have an 8th degree, okay, I have an 8th degree. What is my R of my 5th term? 4. Because why? We start out at 0. All right? All right, so that's kind of how we find these beginning coefficients of it. All right? So if I use my 7th row, I have my 7th row to build my 8. So what's my first term always? 1. And if it's an 8th power, guess what my second one is? 8. All right? Now, you probably don't remember your third term. You probably don't remember your third term on your 8th one. However, if you look at Pascal's, guess what my third one is? It's 28. Now, that is really 8 combination 2. Okay? Because what's your R for your third term? 2. Okay? Because you start out at what? 0. Fourth term. Going to find my fourth term. So what's my fourth term here? 56. All right. What is my R on my fourth term? 3. All right. All right, let's do another one. So I need my fifth term now. We'd have 70. All right, and now we're kind of on the downhill slope. What would be my next one? 56, and then 28, and then 8, and then 1. All right, hello.
Okay, when you kept asking what's my...
What power do you want? Pick a power. 11th power. We have an 11th degree. Why not? We have 11th degree polynomial. What term do you want? What term do you want, Mariah?
7.
We want the 7th term. All right. I want to find my coefficient before I do anything. And so that would be 11 combination what? 6. Why is it 6? Because we start out at 0. If I know that, I got it all. I really do. All right, so then I just do 11 combination 6 in my handy dandy calculator. All right. You know what? Yeah. Do it. And what do we get? 400 and what? 62. Now, would Pascal's triangle be a good use if we do an 11th degree? Probably not, okay? It's very limiting because it's so short, all right? All right. Binomial expansion of x plus 1 to the power of 3. Now, I always like to start out with my coefficients. So I have a power of 3, so how many terms am I going to have? I'm going to have 4 terms. What are my coefficients? 1 and then 3 and then 3 and then 1. All right? It's got to be 1 and 3 to start with, but I got 4. I'm already down my downhill slope. All right? So here we go. So now I have 1 times my first term. What does my first term do? It what? Descends. All right? So now we have x to the power of 3. And then plus 3. Now I have x to the power of 2. And then I have 1 to the power of 1. And then plus 3 times x to the power of 1. And then 1 to the power of 2. And then I have 1 times 1 to the power of 3. All right. And then we just got to simplify it up a little bit. So my first term ends up being x cubed plus 3x squared, and then plus 3x, and then plus 1. All right, let's do another one. So this one, we have the quantity of 2x minus 3 raised to the power of 4. So I always like to start out with my coefficients. Okay, how many terms am I going to have if I have a power of 4? I'm going to have 5 terms. All right, my first coefficient before I work with anything is going to be 1. What's my next one? 4. Now, let's say I don't remember this third one. My next one's going to be 4, and then what? 1. Now, how do I get this one without building Pascal? Let's say I don't remember Pascal's triangle at all. How do I get that one? That would be 4 combination what? What is my R of my third term? 2. I'm telling you guys, if you got your R, you got it all. Okay? So that's 4 combination 2. So I can put that thing in my handy dandy calculator. And what do I get? I get 6. All right? if you understand how r works, this is not going to be that bad. Okay, if you don't understand how r works, this is not going to be fun. All right, so now we're ready to go. So now I end up having 1 times the quantity of 2x to the power of what here? 4. All right, we're starting out with 4. And then plus, now I have my coefficient of 4.
Why didn't you do anything with the -3?
Well, it's a -3 to the power of 0. I could say that. I don't usually say that. Do you want to say that? I don't usually say that because what's the power of 0? It's 1. All right, because what do these have to add up to again? They have to add up to 4. All right, so then I have plus 4 times 2x to the power of 3. Remember, we're descending, and then we're going to ascend. So then I have -3 to the power of 1. And then plus 6, and then 2x to the power of 2, and then -3 to the power of 2. And then plus 4 times 2x to the power of 1, and then -3 to the power of 3. And then plus 1 times -3 to the power of 4. Okay? You could say 2x to the power of 0. I just don't usually put those. All right? All right, now we got to do a little bit of math. All right, so now we have 2x quantity to the 4th. So 2 to the power of 4 is 16. So now I have 16x to the power of 4. All right, and then, well, it's actually going to be minus. All right, so then we have 2 to the power of 3, which is 8. 8 times 4 is 32. 32 times -3 is -96x to the power of 3. All right. All right, now we got to do a little bit of math here. So 2 to the power of 2 is 4. 4 times 6 is 24. And then -3 squared is 9. 9 times 24 is 216. X to the power of 2. All right, you guys are more than welcome to use your calculators. You got them. All right. All right, so then I now have -3 cubed, which is -27 times 4 times 2, which is -216. And then I just have x. All right, and then I have -3 to the power of 4, which is 81. All right. All right, let's do another one. So now I have x squared plus 4 quantity raised to the power of 3. Again, I always like to start out with my coefficients. So what would be my coefficients? 1 and then 3 and then 3 and then 1. Okay? All right. So now I have 1 times x squared to the power of what? 3. And really, you could say 4 to the power of 0. I just don't. All right. And then plus 3 times x squared to the power of 2. And then 4 to the power of 1. And then plus 3 times x squared to the power of 1, 4 to the power of 2. And then plus 1 times 4 to the power of 3. And then we just have to simplify it a little bit. What is x squared to the power of 3? X to the 6th. When I have a power to a power, you multiply. Okay, when you have a power to a power, you multiply. All right, so this is x to the power of 6. And then plus, let's work with my numbers first. So I get 12x to the power of 4. And then let's work with numbers first. So then we get plus 48x squared, and then plus 64. All right. I need to find the 4th term of 2x minus 3 quantity raised to the power of 8. All right? Now, would building Pascal's triangle probably be useful in just finding one of those terms? No. Okay, let's just go straight there. And so I had you write this down at the very beginning, and we're going to use it. So it's n combination r, and then x to the n minus r, y to the r. Remember? All right, if you understand that, it's not too bad. And if you can get your r, we're ready to go. So if I have to figure out my fourth term, what is my r of my fourth term? R is equal to 3. Okay? So what goes out front is our 8 combination 3. All right? And then we have the 2x quantity to the power of something. And I can't do that one first for some reason. And then I have negative 3 to the power of what? 3. All right? I always do that one first. Okay, I've been doing this for a little while. I always do that one first. Because now 2x is to the power of what? 5. Okay? You can, I know some people are probably better than me. They can do 8 minus 3 and they could say 5 right there. I always do the second term as 3 and then figure out what I need to add up to 8. All right, figure out what I need. All right, so now let's do some math. So what is 8 combination 3? 56. All right. Now I have 56, and then I have 2x to the power of 5, which is?
32.
That'd be 32x to the 5th. And then I have negative 3 cubed, which is? Negative 27. All right. So now, good thing I have a calculator. I need to do 56 times 32 times negative 27. And I end up with negative 48384 x to the 5th. All right. Worksheet 9.5a.